Welcome to Hi, I Like Maths Forest. Just for our audience, Forest is working with an old friend of mine, Puyan, and that's how we got to know each other. I had an episode recorded with Puyan, and he talked about AI and stuff that he's really interested in, and I think it's pretty cool. And then through him, I got to know Forrest, and he has quite interesting stuff to talk about as well. So I wanted to have him today, and then I would like to start with asking some questions about your background, like where did you grow up? What did you think about like professional career, whatever? What's your passion in life? And let's take it from there.
Sure. So, hi, everybody. My name is Forrest Agostinelli. I'm an assistant professor at the University of South Carolina in the Department of Computer Science and Engineering and a faculty member at the AI Institute. So I grew up in Washington, D.C., and I actually first started getting interested in just AI in general because my mom was a secretary at the Electrical Engineering and Computer Science Department at a Catholic university in D.C. And she worked for the dean, and I still remember him, Dean Charlie Nguyen. And so when I was like 6 years old, he'd show me the labs and stuff, and it was a bunch of robotics stuff.
Right.
And I just see it, and I was like, I don't know what this is, but I'm gonna do whatever this is.
Really?
And then even it was like just automatically like I wanted to do it. And I even got to sit in like some of the college classes and stuff, just like at 6. And so that's really why I like wanted to do this.
Right.
And I remember when I got this job, I actually emailed Dean Nguyen and told him like, I got this job.
I eventually made it. I made it.
Yeah. Because I would ask my mom, I would say, can you get a promotion and get your boss's job? Really? And she'd say, you have to have a PhD to do that. I was like, okay, well, I guess I'm getting a PhD.
I get a PhD. So, and I want to be your boss. Excellent. Yeah. What an interesting story. So how your career path look like since then? Since childhood and that passion and that stories. So.
Right. So I was in high school, you could take electives and things like that. So, you had a good amount of freedom in high school. So I would take a bit more like physics and chemistry and math, also music. I've always been really into music. Yeah. And so, nothing really spectacular in high school. I was always a good student, but I wasn't like inventing anything. But I was always like a good student. In undergrad, I didn't really know what any of it really was, like electrical engineering or anything like that. But I remember in one of the intro classes, they were like, if you want to do robots, you should do computer engineering. So it's under electrical and computer engineering, but with a computer engineering focus. So my undergrad was actually in computer engineering. But in my junior and senior year, I took some artificial intelligence classes. I took a neural networks class, and I was like, this is really cool.
Right.
Whatever this is, I want to keep doing this.
Right.
In my undergrad, my professor invited me to do their little like research group. So they invited me to be a part of it. And I still remember like Professor Paolo Bucci and Professor Bruce Whitey. Yeah. And they just knew like I really like computer science, and I was doing like extra stuff in the class. And so I didn't really know what I was doing, but I would just do, research in terms of like chatbots and trying to catch child predators online. I didn't know what I was doing, but I was like, you could, that show To Catch a Predator? Yeah. 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 So, I watched a few episodes of it. Yeah. Yeah. It's remarkable when you like just see like the kinds of people that come in. But, there has to be a person pretending to be a kid online to catch them in the first place. And so I was like, what if you could build a chatbot that was designed to catch predators? And so that was like the whole research idea I was doing. Wow. And I was just so lucky, to have just such good advisors in my undergrad, that would like even listen to whatever I was saying.
Yeah.
And, they gave me so much encouragement.
Yeah.
And it was just kind of out of the blue. Professor Bruce
Mm.
Whitey was like, oh, you should be a part of this group. And I
Right.
was like, okay, sure.
Excellent. Did you end up making the chat bot?
No, I didn't really know what I was doing. So I made a chatbot
Right.
based on just stuff I would read online. I would just read a bunch of stuff and throw it into, whatever I was making. But it wasn't like a sophisticated chatbot.
Right.
But I made a chatbot, but it was not very sophisticated.
All right. I think this is a kicker start. I think the main part of it, or the whole, I would say, point of doing it is just getting to know the whole things and being taken seriously and take it to the next level and create something. I think that gives you a huge self-confidence, if I'm not mistaken. And was it like that?
Mm-hmm. It was because, I don't know, for some reason I always felt like I wouldn't, not that I wouldn't be able to, but if I asked to be in some type of research group, I'd be told no. I have no idea why.
Really?
But I always felt like I'd be able to do things, but I was just like, oh no, you have to be like a special guy. It almost seemed like preordained who got to be in what.
Yeah.
For some, I don't know why, but then when I got to be a part of it, then I saw like, oh, things are a lot more just, you can do a lot more things than I thought I could. So it was weird because I always thought if the problem was in front of me, I could do it. But just like getting to the point of someone saying like, you should work on this problem, or, I'll mentor you, that was the hard part for me.
Yeah, it's quite a funny one because I've had that so many times as well. And I remember when I was doing my postdoc at USyd, University of Sydney, we started building up a group to work on kind of, an analysis of brain scan data. So they got the scans from the brain, and then our job was to analyze it and see the connectivity network of the brain, and then compare healthy versus depressed or bipolar. And it was quite a hot trend at that time. And it was one of the kind of the really challenging problems to deal with as well, because working with brain is quite difficult because it has like the noise level of it is insane, and also the dimension of the problem is quite huge. But I was constantly kind of, I was part of it and I was actually doing the work, but deep down I was also thinking, am I actually part of a quite a gigantic team working on quite a hot topic in the world as well? It was just a quite weird thing that I don't know if it's come from self-confidence or it's just something else, but I've experienced it a few times.
Yeah, that's true. And I was lucky enough to have like enough confidence in myself, like in the sense that I never felt that I didn't have the smarts. I just felt that you had to be like, it almost felt like you were preordained from since you were a kid to do research, and no one told me I would be doing it. So I almost felt like it's so strange. I don't know, but yeah.
Well, I get what you mean.
Yeah. After my master's in the University of Michigan, so I published a paper, research with neural networks, and then I decided to actually switch from University of Michigan, where I got my master's, to UC Irvine, partly because my advisor, Pierre Baldi, he actually messaged me and called me up when he saw my application, and he was telling me about all the research he did, and it was a lot of this interdisciplinary research. So he had research on bioinformatics, physics, chemoinformatics, these things. And I always wanted to do something that involved fundamental research that could then immediately be applied to a real world problem. So, I thought this was a great opportunity. And so that's why I went to UC Irvine. Yeah. Wow. And so there I did research on bioinformatics. It feels good as well.
Working on it, kind of the real problem that, I don't know, is it for you is kind of an impact that you make, or is just cool working on real life problems or something like that?
The real world problems really, for me, drives the search for new discoveries in the field of artificial intelligence itself. Like when you come up with a new AI algorithm, a lot of times for me, there's, for my own research, a lot of it was, there's this problem I want to solve. I can't solve it with this method, that method, the other method. Well, I have to come up with some new method or put methods together that can be combined to solve it. And so that for me is the driving force behind it. And so, real world problems are full of, of instances where AI hasn't yet been able to solve them.
Right. Oh, excellent. Right. I haven't looked at it that perspective. For me, it's just normally working on real life problems. It's just a matter of impact and just doing something meaningful. That's kind of something that drives me to work on. But in terms of methodology, I think that's quite a great approach as well, because we do need quite sophisticated and advanced methods to deal with quite complicated problems as well. And real life problems are very complicated. So you can't simplify it. When you simplify it, you get some sort of answers, but which is not wrong, but it's just I would say just one way of looking at things. Right. So you got a PhD in there, and then what happened after that?
So after I got my PhD, I was just at my same institution, UC Irvine, for a few months doing a postdoc.
Yeah.
And then I got this position at the University of South Carolina. So I was there only like a few months after my PhD, and then on to South Carolina. And now I'm here.
Right. Excellent. Yeah. Have you found it hard to get a kind of research position after doing PhD, or it was just kind of easy? Because
I wouldn't, it was like, it was, hard in the sense that when you're applying, what people are looking for is, can this person do this line of research for the next 30 years? Which is really, when you're applying for a job, people are like, what are your skills? What can you do? We have these things that are, we're trying to come out within a year. Can you do this? But then you're thinking like 30 years down the line. And so it was kind of hard thinking in that way at first, but then you realize that, your research has a lot of different directions that it can go in, and these directions could be open research problems for, decades. And, that part I think was different. The application process was actually pretty fun. I liked it a lot, but you have to think a bit differently.
Yeah, I get that. All right, talking about AI, and I guess anybody knows that how hot this AI is these days. But because you worked quite intensely in this field and did a PhD, and now you're doing research in this field, I'd like to ask this question: why you think AI? Why you think is important, and how do you see the future of it? Because for some people it's quite horrifying, and some people really like it. So how do you see it?
So for AI, I think the things I'm most excited about, and this is going to be biased towards my own research, but what I'm most excited about, I think, is the knowledge discovery part of it. So a lot of my research focused on solving sequential decision-making problems. There's a sequence of decisions you have to make to solve the problem. So some really accessible versions of sequential decision-making problems are puzzles. So like the Rubik's Cube, sliding tile puzzles. We studied some other puzzles as well. And, we developed algorithms that were fairly domain independent. You just describe how the puzzle works and it can figure out how to solve it. But then what we're interested in is, say you don't know how to solve these puzzles. Can it explain to you how to solve it? Can you give it ideas and it build off those ideas? And so everybody could have their own way of solving it. And then, this extends to, what if you want to synthesize a chemical for medicine? What if you want to prove a theorem in mathematics? Can you collaborate with AI and you all both learn from each other to solve this problem? So, this knowledge discovery to me is really exciting. And I think we can, just push the boundaries of what we know using AI, work together with AI to learn new things. And also it could be used as an extracurricular learning tool. So if you're interested in something kind of quirky, maybe not too many other people are interested in, maybe you can collaborate with AI to learn more about this thing that you're interested in. So that's what I'm really excited about. Now, what people, and for good reason, and including myself, are wary about is what happens when AI starts taking people's jobs and makes it hard for people to live. And so for me, the way I look at this is, you know, I'm at University of South Carolina. This is a public university. And then even people who aren't in public universities get a lot of funding from the public. A lot of private companies get a lot of funding from the public. So it's like, we all go to work, and this isn't just AI, a lot of different areas, including medicine and things like this, publicly funded. And so we all go to work, we work hard, and a portion of what we make goes to this research. And so just simply, everyone should benefit from it. So, you know, we're all paying for it, so we should all benefit from it. I think it's that simple. And nobody should be forced to work, have some of their money go to something that's going to disenfranchise them in the future. So, you know, in an ideal world, AI takes your job. You have more free time to go pursue something else you might be interested in. But in this world, AI takes your job, and now you're wondering how you're going to eat, how you're going to get medical care, where you're going to live. And I just think that's wrong, because you worked really hard to make it a reality. Those things that you were accustomed to before should still be guaranteed, even if AI takes your job. So that's the way I look at it.
Yeah. What are those examples? What do you think about? Because I never thought about such a thing, actually, but I like to see if you had any thought on that. What are the things that people can do, actually? If, for example, you're a medical doctor and your job already is taken by AI, you're a psychologist, and sorry, but we have an app that can do the things. Well, or even teachers. I don't know, but if there heaps of stuff online.
You just listed 3 professions that I don't think AI should ever take these people's job.
Really?
Doctors, psychologists, teachers, I think should be human always. I think AI can be used to enhance what they do, but I think it's very important humans be the ones making, you know, decisions here. I think they can be enhanced in terms of AI helping them do a diagnosis. But it's so funny because you just named 3 professions that AI, I don't think will
because I read books and I've heard all these stories that and the concerns as well that you know, these kind of people can be jobless because of it. And I was thinking, well, what if actually, you know, and but you know, I'm in education space, and you know, deal with teachers, our teachers well. And well, it's I guess it's just the hard time for teachers to think about a day that is just completely out. We don't need you. But over time, I realized that teaching is something that it's just highly connected to your interaction with your students. Even if you have all different sorts of apps and you know, online materials and things like that, still the students need that connection. So it's part of it, is ingrained within us. So yeah, over time I realized that you can't take it. So you might need to change your role, the way you run things. That's kind of something that I would like to work on, because I create a lot of online content and apps and things like that. But I like to change the way teachers deliver their stuff. You know, just get out of that teaching mode and just focus on leadership, and then how you deliver your content, kind of, you know, make it kind of fun, interesting, challenging for students, rather than just go through with things and teach it. That's kind of something that I'm kind of interested in. And yeah, but it's just, I guess, it's a concern for so many people that, you know, they're freaked out by the idea of AI taking over.
Right. And in terms of what to do, you know, I'm not going to pretend to be like an expert on this, but what, you know, you think AI takes someone's job, it's because it's more efficient and saves money and things like that. Obviously, I think these savings that people have worked to make a reality should also be passed on to the people that had those jobs. And one solution people think about is, you know, universal basic income, maybe with some control on, you know, price of living, cost of living, and things like that, like rent control or certain things to make sure these markets don't get out of control. I'm not an expert on it, but I just think on a high level, when people don't have to worry about these basic things, and we're just so much more productive, we can actually afford for people to not worry about the basics of where am I going to live, how am I going to get healthcare, what am I going to eat. This just frees up people's minds to go pursue, who knows what's next, like, but just to pursue all sorts of things. When your mind is free from the basic worries, you can really spend time doing all sorts of other amazing things. And it's like, even like, who knows what could possibly come out of it, new art, new areas of science, and just new knowledge, like, just who knows. But I think it would be a beautiful thing if people didn't have to worry about these things and were free to really just do what their heart really wants to do, instead of having to worry about
just worrying about how to survive,
just eating.
No, I get that. I read a book, and I was just talking about AI things and the concern about that, and the author mentioned that people probably can philosophy and psychology probably get more popular at that time, because people have time to think about I would say basic questions, skill sets. What do you think? Because I know how much you like it. What kind of skills, if anybody else is interested in these AI things, what's your recommendation? What they actually need to focus on and get better at to be able to work in this field for companies, as for research, whatever you suggest?
I mean, one thing is just programming, and there are a lot of different aspects of programming that could go into things like this. So in programming, I think of this as something you really have to practice, practice, practice. And I didn't fully appreciate it until I started teaching at the University of South Carolina, because some students would take my classes and they come from a different discipline that didn't focus so much on programming. And some of them would be fine, because I think they still programmed a lot, but others, they programmed just enough to do, I don't know, like they were doing something in, say, mechanical engineering or something like this, and then would have a really difficult time with coding assignments. And then I appreciated just how much practice went into, getting good at programming. But then also, there's so many different aspects that can go into a single research project. For example, in past research projects, not only you're programming in Python, but then you need to program in C++ when you want certain parts of it to go faster, especially if, you're working on publishing a paper and you're comparing to other things that were implemented in C++. Okay, now you have to know how to do C++. Oh, now you need to do this parallel programming part over here. And you have to be good at algorithms. That's always, computer science is algorithms. So, you have to be able to analyze how fast this is going to run, which parts are the most important parts to work on, these different things. Also, just a little bit about the architecture of the computer, things like that. There's just, these things all can come into play into a single project. And so just knowing about computers, how they work, and programming is essential. Math is also very essential, and to different degrees, depending on what you're doing. Some areas of AI, especially involving proofs and things like that, can be very math heavy. Some areas of AI actually don't appear on the surface to have much math required. A lot of it is abstracted away. But I think that kind of thinking, being able to think abstractly, and being able, like I said, with algorithms, being able to figure out what that runtime would be, requires some type of mathematical thinking. I haven't been able to put it all together. It's not like you need calculus, or something like that. But I think definitely a discrete mathematics course is essential to being able to work with computers.
Well, what level you expect them to be? Like bachelor, or just have bachelor degree in maths, or just doing double degree computer and maths together, or do they just need to go beyond that?
For the computer science students, the background I expect them to have, I expect them to take calculus, you know, up to multivariate calculus, have taken differential equations, have taken linear algebra, know about statistics, probability. So that's essentially what I expect their background to be. So that most computer science students have taken this by the time they get their bachelor degree.
Excellent, excellent. Well, as a maths person, I did a PhD in applied maths, but right from the beginning, I did applied maths in computer science. So I've noticed that maybe from maths perspective, you need to go beyond bachelor degree if you actually want to do substantial work in that space. But it's all about kind of what you want to do, right?
Yes, and no, for sure. For that, when it comes to like actually analyzing, you know, the properties and getting theoretical guarantees, you definitely have to have more than bachelor's degree level, you know, of math.
Cool. Right. So far, programming and mathematical skills. Anything else you think is needed?
You know, a lot of what I say is like just what I think is that you just kind of have to be clever in the PhD, because so much of AI is just kind of like sneaking around NP completeness. You know, you're just kind of like tiptoeing around this way, hoping it doesn't get you going like that way. And I think a lot of it is just being a little bit clever, you know, and just a little bit creative. And so, you know, I remember my advisor in my PhD like would be excited if a student was into like music or something like that. Like, you know, I'm into music, he plays the guitar, and he would just be excited if students were into different things. And I think because he thought like that would, you know, make them a bit more creative or something. I don't know. But I do think you have to be like a little bit clever, because you have to sneak around the fact that if you just approach this problem head on, it's just not going to work, because something is just going to grow exponentially or, you know, with its size or something like that. So you kind of have to sneak around that, sneak around this.
Right.
So, yeah.
Right. Being creative and think outside of the box. So what you're trying to say. I found it quite difficult,
like that.
Yeah. I found it quite difficult. I don't know what's your experience, but creativity is kind of I think it's quite a hard thing. Is it I don't know where it does come from actually, but it's probably to do with a lot of I would say, some neuroscientists look at it as a connection between different parts of your brain that normally you don't have that connection, but somehow for some reason these neurons start connecting, and then it just fires a new idea. I don't know how you look at it, but I found it quite challenging in that sense.
This is a big thing I think about with my research, because like imagine just with solving the Rubik's Cube, you can solve it hundreds of ways, and I've seen all these really clever ways at solving the Rubik's Cube. And so, you know, the AI is coming up with its own way of solving it. You know, this is still like research that's ongoing. And you know, can you actually have a metric for like this kind of aha moment? You know, how does the computer actually think creatively? Because you know, in the back end, it's some algorithm, there's something running. Usually with my research, there's some neural network in there. How do you get to that moment where you just like, you know, you just look at the problem in this different way, and you go, oh, you know, whoa, okay, let's do it that way. And trying to think about that computationally and actually identify it is, you know,
Do you think computers can be creative one day? Like this aha things is, I don't know, it's just, I think it's very unique about human being. But I don't know, can you see that like happens in AI field? Can robots and computers get to that point?
When it comes to this aha moment, so Zygmunt Pislow at UC Irvine, he looks at how humans are able to solve these NP complete problems in a relatively efficient way compared to a lot of computers. and what it really means to have like insight into a problem. And he talks about when you change the representation of the problem, and how this can lead to solving the problem a lot more efficiently, or getting some insight that you previously didn't have. And so I think when it comes to creativity, like that's part of it. And I'm just still thinking about the whole space of the problem, and you can think of all the possibilities, the configurations the problems can have as this big set, and then you can break it up into these different subsets, and maybe finding a way to think of this new subset of states where you couldn't have thought about it before in the previous representation is like some type of insight, and then it has nice structure when you think about it that way or something. I'm not sure, but his whole idea about changing the representation of the problem and how that gives you new insight, I think is a big part of it.
Also, do you think the fact that we have a luxury of having having facilities, quite advanced one, to make this computational work easier and faster compared to the past, and I think in future it gets even better. But do you think the fact that we can play around with kind of different sort of orientation or different sorts of combination, and that we normally might not be able to think of, that can give us also an insight? Because that's a random process, right? So a computer can generate all different sorts of possibilities and combination, and is just doing it randomly, maybe even based on the way you designed it. And then you look at it and say, oh, maybe that can work. Oh, maybe I can, add this one to that. But it's just the power of algorithms that can give you kind of a different sets of solutions, or I would say possibilities, that makes you to think about insights or this aha or creativity kind of creative ideas later on. Do you think that can contribute to it?
That's a really good question, and I think it contributes a little bit, but I think we're under the illusion that that is the answer, and I don't think it is. Because if P does not equal NP, I don't think any realistic advances in silicon-based computing is ever going to allow us to look at a meaningfully larger set of possibilities, because if P is not equal to NP, just the space of possibilities is so huge. There's no way that silicon-based computing is ever going to take a big enough chunk out of it by just being able to process more efficiently. You have to think a bit more in terms of, how can I identify some sub-problem and solve that and build on top of that? Or, how can I really think about having good heuristics, just pointing me in the right direction, but, I'm not going to know for sure. But, that's really what I keep thinking about when it comes to this explainability, because I can't look at every possible way I can solve the problem. I can build a heuristic function that kind of points me in promising ways. But then I think that really aha moment comes when you find something unexpected that the heuristic function didn't expect, that's kind of in this other direction. And getting there just by using brute force computational power, looking at as many possibilities, as many options as possible, only works up to a certain point, and then I think it'll just kind of fall off a cliff, just because if complexity is just going to grow exponentially with the size of the problem. So what do you do in that case? And that's kind of what I hope to understand better.
Right. Excellent. And I guess at the end of the day, it's about evolution of ideas. You just take what's there, and then you add your insight to it, take it to the next level. Maybe over time you improve it, maybe other people will join and they put their ideas next to your ideas, and then something better comes out of it. So are you kind of I wouldn't say idealistic, but perfectionist in that sense, that I'm just going to come up with a best method to deal with that, or just you're cool about it, so I'm just going to take it as it is and see where it goes.
You know, I whenever I'm coming up with, you know, I'm working on an idea, I always get sidetracked with like, okay, it can do this now, but like it can't do all these other things. And the space of other things it's not going to be able to do is always going to be just huge. And so I do think I kind of get sidetracked and thinking ideally it should be able to solve this entire class of problems. You know, in artificial intelligence, we like to classify problems and say this is a supervised learning problem. Or, you know, this is a pathfinding problem. You know, this is a reinforcement learning problem. You characterize it, and then you come up with algorithms that can ideally solve any one of these, solve any instance of that problem in that class of problems. And so, you know, you build the framework, you know, you think about things in a formal way. You know, what is the class of problems? You know, define that class of problems formally, and then define how your algorithm would work. But then you think, oh, but in this instance, oh no, it's not going to work. In that instance, it's not going to work. And so, you know, this is just always going to be the case, and I really do get sidetracked by that.
Right. Yeah, I get that. When we had a chat first time, you mentioned that you work for a few companies as well. Would you like to talk about that a bit? Like what type of kind of analysis or job you had there?
So all of the work I did were all internships, you know, and this was throughout when I was going to school. So I had 3 internships with Intel in the Bay Area. I had an internship with Adobe in the Bay Area, Adobe Research. I had an internship with Microsoft Research Asia in Beijing, China. I had an internship with DeepMind in London. And then I had an internship with Sentient, which is this startup in Southern California in Irvine. So, you know, I've had a good amount of internship experience. And so I have a pretty good idea of, you know, what it's like. And in terms of the skills, you know, this was the big difference in the application process, because for the companies you're trying to show off what you've done that's relevant to that company, what your skills are. In some of the interviews, you know, they'll have some coding interviews, and then they'll have a lot of parts of the coding are like actual, what would you actually write? And then other parts are like on a high level, how would you approach this problem? And so that's, you know, when it comes to what would you actually write, that's usually just your familiarity with the languages. And then, you know, some of the more difficult ones are, of course, like C++, you know, and the lower level languages, you know, Python, Java are higher level. So you don't have to get into the nitty gritty of how are you going to save memory and things like that, because they have this automatic garbage collection. You still have to worry about memory, but not at this lower level. And then when it comes to the high level, how would you solve this problem? That's a lot of the algorithms. So, you know, just knowing, oh, this algorithm has this runtime or something like that is often really useful. And then sometimes they'll ask if it's related to machine learning. You know, you want to be able to differentiate between different methods. So, you know, and this is probably true for whichever field, they'll ask you, what's the difference between this method and that method? When would you use this method? So on and so forth. What are the theoretical guarantees of this method? And things like that. And so they'll also come up with these hypothetical scenarios. You have this data. What are you going to do to pre-process it? What are you going to do to make sure it's clean? Those types of things. Or they'll present you with some problem and say, how would you solve this problem? You know, just what machine learning methods would you use? Yeah, so that in terms of the skills, it's like algorithms. That's so much important with computer science, and then just practice with programming. Yeah. And that's the big difference between industry and academia, because academia, it's kind of assumed like, sure, you're in computer science, you can code, you know about algorithms, but like, what are you going to do for 30 years?
Yeah, that's true. So if someone is interested in working for companies, they need to focus on programming skills a lot and learning Python and C++. Are you into R at all? Because I use R for teaching mainly.
I have used R. I'm not a fan of R, but I have used R. I built a whole like neural network in R from scratch
Right.
to do this bioinformatics thing because that's what
Yeah.
bioinformaticians use.
Yeah.
But then I switched it over to Python because I've used R. Yeah,
You just don't
I've
like
used
it.
it.
Is it true that engineering mainly like Python and statisticians like R? Is that true? Because I've heard it so many times. But do you think that's
well,
true?
well, R does have a lot of built-in functions that statisticians can use that other languages you have to, do a bit more work to actually get to work. So R does have that, which is very convenient for statisticians. I've seen engineers mostly like Matlab, I think.
Mm,
I've seen that used a lot in engineering as Matlab. Even when I was doing, the computer engineering program in my undergrad,
right,
we almost mainly use MATLAB. The only reason
right.
I know like C++ and Java is because I did the computer engineering side of things.
Mm,
I don't even know if electrical engineers would have been too, I mean, definitely the C++ part, but I don't think it would have been too heavy. It was just like mainly MATLAB that they would
right,
use.
right.
But now Python is getting a lot more popular. I really like
Mm,
the language, especially with the fact that they now have these type hints. I didn't like the fact that it was just dynamically typed. It's still dynamically typed, but you can kind of pretend it's statically typed, meaning like the type of variables can't change.
mm,
You can kind of pretend it's not with
mm,
your documentation and the type hints, and then your IDE can give you a warning sign if it's not the right type, which I think is great. And so I really love the fact that it's interpreted. It's an interpreted language, and it's you can kind of pretend it's statically typed. So
right.
I think that's one of the reasons it's getting so popular, and you can do a lot with Python. It's amazing all the things you can do. So I think it's really growing in popularity. But
Mm,
MATLAB is like this language that you can do a lot with the linear algebra packages. It's not as strict of a language as of course, like Java or C++,
mm.
but you can do a lot with MATLAB as well.
Yeah, yeah. I used Matlab during my PhD,
Mhm.
and but I didn't deal with like a huge data set, and it was kind of fine for research components part
Mhm.
that I did. Um, but over years, I've noticed that people start kind of, liking Python more. And I was thinking, well, Python and R, they're free resources, like, open resource. So
Mhm.
people can just use it for free. But you have to pay for Matlab. So I was thinking that how these
It's
companies can
expensive.
convince people, and it's expensive. Yeah.
Mhm.
So, but probably if you want to work for a company, companies needs to pay for it. And
And when
uh,
we started doing, when I was doing deep learning, like there were no packages or anything. We did actually almost everything was in MATLAB.
mm,
And you could do the GPU stuff in MATLAB, and MATLAB had really convenient profiling tools. I think it's like all these tools you can click this, click that, and
yeah,
do a lot of convenient things in MATLAB. But
yeah.
then it was like C++, where that was like the first deep learning package was in C++, and it was really
Mm,
fast. And
mm,
then Python came along and it was more user friendly.
right,
And then finally, people have made something that's fast and user friendly in Python.
right. Yeah.
Yeah.
All right. So focus on Python mainly, C++ after.
Yeah, I mean,
MATLAB if you like to. But
I,
MATLAB is not complicated. But I haven't found it complicated. I mean, coding in MATLAB, but I don't know. That's my experience because I've used it a lot before. But because it's just I don't know. It's a lot of inbuilt functions, so make it easier for do a bit of coding and it, as you said, it has heaps of packages as well that you can play around with it. But, great, and
right.
obviously a bit of mathematics just on side. I would
Definitely not on the side.
not
I think definitely should be also part of the main thing. Yeah. But you can get pretty good at programming not knowing too much about math actually.
really.
People get really good just doing it. But I think when
Mm,
it comes to applying it to a real world problem, math is extremely important.
yeah,
So yeah.
yeah. No, I get that. Do you think Excel is still is something that people should learn and use it, or one day
Um,
that will be vanished? Because Excel,
I don't think it
Microsoft is
will.
pushing a lot to keep it still.
I don't think it'll ever go away. We did in undergrad, we took one class that for a bit we had to learn some stuff about Excel. And I'll use Excel if I'm like doing a budget or something. But
Right,
besides that, I don't really use Excel.
right.
Um, but it's convenient for visualizing things.
I think so.
Um, yeah.
And do
So,
simple, very simple calculation is quite easy. You just,
mhm,
grab columns and then insert this and that. So, but
right. And earlier, when I would do plots for like a paper, sometimes they would come from Excel. Now
mhm,
almost all of them come from Python. That's the other thing is you can make beautiful plots in Python.
right,
So
yeah.
almost all of them come from Python now.
Oh, I
Yeah.
get that. It's hard to like getting used to something like Python or programming actually language, getting all these cool graphs and move to
Mhm.
Excel. And so what I'm going to do with it sometimes even I lose my abilities to click on things because it's just hard for me to believe that by clicking you can get things out.
Yeah.
Anyway, cool. So, and I think, well, these days, there shouldn't be that much of problem finding jobs. There's so many opportunities. It's just a matter of like literally upgrading yourself and getting yourself kind of, into these maths and computational world and programming and things like that. And try it and try it, and you eventually get something to work. If you would like to work for companies.